today we're out here on I-55 and we have a noise meter set up, and this records the decibels of the passing traffic on the A-weighted type system, where you actually, that's what the human ear can hear. So it's weighted for that. And normally, while we're this close, we don't have it this close to the highway generally. Generally it's up near where the receptors are. But just to give you an idea of the noise down here, we're running from anywhere to 60, 70, 80, I saw 88 decibels this location. And this is traffic that's in a chute with a little bit of protection on the median barriers. It's also not the highway speed that it's going to be once this project is completed. Normally we would take this, put it by the receptor, we would record the decibels, count the traffic, and then we take it back, and there's a modeling program. It's called TNM 2.5 that we input that, we model the highway, we put that information into it, and we see how well we built that model compared to the real life situation that we recorded. So that's why that's the function of this noise meter. Generally, we are measuring the tire pavement interface, which is the loudest, but also the engine noise and the exhaust noise too. The engine noise, that'll come into play on semis if you can hear it as they're passing by, and then exhaust too. But by far, the pavement tire interface is where you get your most highway traffic noise.
I'm on the other side of the wall here from 55, and on the highway side, we were consistently hearing about noise in the range of the mid to upper 70s. On the other side of the wall, now we're ranging between 60 to 65. So you can see there's a definitive difference in the noise that you're hearing on each side. It's a lot more peaceful back here. We can have a conversation, and the wall is not actually entirely complete. So we're seeing the benefits even though we don't have our entire wall set up. But it is definitely a noticeable difference for residents that live on the other side of these noise walls. We are looking at a wall that uses a special material. This material absorbs sound. We use this material when we have walls that are on each side of the highway. This parallel wall system requires one of the walls to have an absorptive material that can absorb some of the sound so that noise doesn't bounce between the walls. So right now the bit they have in that casing, that is for soil. So sandy soils, clay soils, or soils with some rock. This apparatus right here, this is for when they actually want to place that casing. You can see that it has the 4 points that match up with the notches in the casing. This bit right here, this is actually for rock. It has bits that are made for cutting into rock. These bolts are embedded in the concrete, and they have this exposed thread, and that's what we attach the posts that we build the noise wall with. Right now what we're looking at is a shaft foundation for a noise wall. This was poured yesterday. You can see that there's some woodwork around here. This is a template that they have in place, and the point of this is it helps keep the bolts in alignment, so when they pour the concrete, the bolts stay in the location that they need them to stay at. So when they bring the post in, it's going to set right on top of these bolts and be able to bolt onto that and provide that structural component. So here's one of our columns that the noise wall panels are set on, and you can see here there's a groove that the panel is just set within this groove.